here we go. This is my first time streaming, so forgive me for any burps that you may experience along the way. My plan for the day is I want to implement RabbitMQ bindings into KumoMTA. I've got my game plan up on screen here. KumoMTA is a message transfer agent designed for large-scale senders. The policy is implemented in Lua. KumoMTA itself is implemented in Rust. The idea of using Lua is to make it easier for someone to express customized policy and to react to things that happen in the system. In particular, one of the features is plumbing log events. Rather than log them to a file on disk, we could send them somewhere else. So perhaps to a webhook. We already have an HTTP client for webhooks, but also to feed them into a message queue so they can be ingested into some other part of a larger architecture. That same facility also allows rerouting messages that come in over SMTP or over HTTP and sending them out over AMQP as well. That's the intent. That piece doesn't exist yet today, so that's the plan, is to figure out how to do that. It should be fairly straightforward, really. It's really just adding an AMQP client to the embedded Lua runtime. So we're going to be figuring out how to do that. I have never used RabbitMQ before, so part of this will be me figuring out like how to run that in a Docker or something. And I also plan to look at some of the different Rust clients that are available for AMQP. There's quite a few. I took a peek on Crates.io over the weekend, so I don't know which are good, which are bad. But the surface area should be pretty small. I think the functionality should be fairly explainable. So I think this will be kind of an interesting little session to get a peek into like how this kind of thing works, how to wire this up in Rust, and well, I guess we'll just see how that goes. So let's first of all, let's take a look at some of these Rust client libraries. Here on Crates.io, I've pulled up the search results for RabbitMQ, and I've sorted by all-time downloads. This is some metric to figure out like whether a client is good. It's not necessarily the best way to figure it out, but it gives you an idea of like what everybody is using, which may be a sign that they're using something good, or at least, you know, it's not terrible. So we can see here we've got this AMQP protocol thing. Let's take a look at this. This looks like a low-level protocol library that explains, or not explains, enables you to interact with the protocol. It's probably not a client in itself, but if we go back and look at its page, we can see like what is using it, and that gives us an idea of which things we might want to use. So yeah, this is lapin, and that's French for rabbit. If my schoolboy French from a horrifying number of years ago is still good. This has quite a lot of downloads. It seems like it might be a good one to go for. Let's have a look at that guy. What does it say here? Bunch of feature switches. It does AMQP 091 and RabbitMQ, so that sounds like it might be a thing. Oh, and here's an example. I guess this is the important thing. But yeah, so here's something interesting. So it's subscribing, and this looks kind of funky. I see, it's just setting up an executor to block on, connecting to the queue server, creating some channels, defining a queue, and then here it's got a consumer. So in our use case in KumoMTA, we're not building a consumer, we're building a publisher. So really I think this part of the example is the main thing. And the Lua bindings for this may just be as simple as make a client that just has a publish method, right? So it should be pretty simple. But there are some different options that you can set on message queues that control like delivery and stuff like that. So like it may be that we need to expose some of that in there. So interesting. So at first glance, I think we should take a look at this lapin library. Let's open up its... Oh, that wasn't what I wanted to open. I thought I opened the docs. Here. Okay, so it explains this in a bit more detail than the example, I suppose. Let's see. Channel contains the methods. And one TCP connection contains multiple channels. That's interesting. And then some feature switches for TLS, which is, if we're honest, a bit messy in Rust. But here we go. And then this is that same example from that main page again. And I think one of the things I would like to see, if we go back to its GitHub page, is looking at its examples and see if there's like a simple publisher. Often the examples in this sort of thing are both a publisher and a subscriber, just for the sake of a self-contained example. That can make it a little bit more confusing to figure out like how to build just the piece that you want. Let's have a look here. Pub Tokyo. So KumoMTA uses Tokyo, so this may be a good starting point rather than that async executor that we saw from the main page. So if we look at this, they've got some kind of URI. So in KumoMTA, our users will want to be able to say like which one it is. So we need some way to expose that. So this is good to see here. Makes connection properties, sets up the executor reactor, connects to the thing with the options, creates a channel. Interesting. So this queue declare, I wonder if every client needs to do this. As I said, I've never used AMQP before. I'm familiar with message queuing in general, but I've never used this particular implementation. So queue declare, and then they've got a consumer again, which we don't want a consumer, we want just the publisher. So I wonder if we need that. Let's have a look. AMQP publisher. Let's see what comes up with this. Reading the docs. Search and handle more terminology. Publisher or producer. Messaging broker. Yeah, nice. Speed this up in publisher lifecycle. Publishers are often long-lived. During startup. So publishing happens on a channel to an exchange, which then routes it somewhere. And this sort of thing, it might be worthwhile me actually just standing up a test AMQP server and having a play around before trying to figure out how to actually write the code. You need to know things before you can define a proper thing. So if I look for something like an AMQP how-to, let's see what we can find. How-to. There's a lot of content. What about AMQP Docker? try that and stand one up. So here I'm just running this Rabbit container. That was easy. Now I want to find a client for it, some kind of command line client. I can see one on here. Let's see if we can find one. There's some kind of admin thing that we could run if we were in that Docker container. If I can get that thing on my Fedora instance here. Yes. Cool. Let's see what subcommands we've got here. Okay, what exactly did I install? RabbitMQ server. Okay, I could be running it actually directly on my box if I wanted to. Lots of checks. Observer. That might be handy for testing reception messages. And status. Okay, so if we do this guy. That's a bit overwhelming for help output. Node. Right, so I want node and point it at my Docker. So I'm guessing something like this. 4369 maybe. Alright, let's read the docs. Rabbit. Oh, I'm gonna have to set up some kind of auth, that'd be annoying. Ah, guest. 5672. It might just be easier to run it directly. Alright, let's shut off the Docker thing. What do I want to do? Stop. And then system status. RabbitMQ. What do we? Because I don't know what I actually installed, I'm just going to check to see what package it was from. -ql. Thank you, sir. What have we got? RabbitMQ. service. Okay. Service. Okay. So enable it. And start it. And then this guy now. All right. So it is up. What else do I need to know? Let's get rid of the Docker one. Oh, hi Chewy Defense, I just saw your message just now. Right, do I know what I'm doing? No, but I know I can figure it out. Cookies. I might have to read one of these basic how-to guides. I'm not going to watch a video. Let's see. Oh, idiots. No, it's on Amazon. Okay, they've got a tutorial. Okay. Maybe we'll look at this Python logic in here. Blah, blah, blah. Alright, let's get this Python thing going. So much of this being a Rust stream. Okay. I see. So in this example, they're saying they create it just to make sure it exists before they start. So perhaps in our bindings, we'll allow you to optionally declare it, and then that will be saying, so we can do qdeclare basic publish. Yeah, so essentially we're going to have a Lua thing that's going to look like these two Python functions. But what I want to do to start off with is just the receiving side. Okay, here's what I want to do. So let's nab this. List queues. Alright, so this simple consumer just calls a callback. and then acknowledges it. Okay, so didn't like that. No queue hello found rehost. Oh, why is that? Oh, because I didn't declare it. Okay. Makes sense. So we definitely did declare it on the receiver. Cool. Okay, so we've got a receiver, and I guess for the sake of just validating the basics, let's do a sender as well. Actually, we don't need the start and sender here. And we'll do the publish. So, if we run the receiver over here, you know what might be using? Let's try that. Let's split top and bottom. Let's run the receiver down here, and then we'll do transmitter. Oops. So. Cool. Alright, so we can send through that thing. It's basically working. So that gives us a thing where we can see that the messages are actually going through. Cool. And my plan now is basically to ignore anything else to do with the AMQP server and just focus on the client side of this. So how best to start on this? So let's talk about, in KumoMTA we have a number of Lua modules and things. So if we look under the crates directory of KumoMTA, you can see these different directories. There's a number of these that have got like mod-something. So what these are essentially Lua modules that get pulled in. They're not dynamically loaded in the KumoMTA implementation. Instead, those are built in statically, and so like in the startup, I might as well just show you that code rather than just waffling about it. In the main part of KumoD, you'll see there's a bunch of these register calls here. So like each of these are these modules being pulled in. So what we want to do is, if we look at mod-HTTP, that's an HTTP client that was added in the last second beta release. Essentially we want to do like something very similar to that module, but it's doing AMQP instead of HTTP. So if we take a quick peek in that module, what we shall see is like the structure of the file in there. So like any Rust module at the top, we've got a bunch of import statements to say what we want to use, but then we come into the sort of specific part here that are KumoMTA specific. So you can see we're defining like a couple of structs and things, and there's this Lua user data thing here. So it's probably worth me explaining what that is. We use a crate called mlua for the Lua bindings. In Rust, mlua is actually really well engineered because it makes it very easy to add and expose types and implement methods and asynchronous methods and properties and all those sorts of things, as well as manipulate data to and from your native code and into the Lua runtime. One of the things that it uses for that is this Lua user data trait that allows you to add those methods. So you can see here, in the HTTP thing, there's a client wrapper that provides these get, post, and put methods. And this is just kind of the glue that makes that sort of tie together. I'm not going to explain this HTTP module here because that's not really what this particular thing is about, but I'm just kind of giving you a taste of like what some of this code looks like. The surface area in here is probably quite a bit larger than what we'll have for the client, the AMQP client, because I think we only need essentially 2 methods on that, whereas this one's more complicated because there's a client that represents a connection for HTTP, and then there's a request that you can configure before you actually start initiating the request, and there's different stages to that. So that one's a bit more complicated, and you can see there's a lot more methods and things being added in here than I think we'll have in the AMQP. So anyway, there's a bunch of guff in this HTTP module, and when we get down to the bottom here, you can see there's this register function that we saw sort of being pulled in the main function earlier. This is the one that provides the main module function. The ones at the top are really methods on objects that are returned from this main thing here. So we'll do something similar, right? We'll have a register method, register function to register our AMQP module and expose it. This method here, function. This function here exposes the HTTP module as mod.http in KumoMTA. Let me show you the docs of that, because none of you have probably looked at this in any detail. So where are those docs? I thought I had a tab handy. Maybe not. Okay, over here. So these are the KumoMTA docs. You can see we've got this kumo.http module, and we have a couple of functions. So you can see we've got this build URL function. This corresponds in the code to this bit over here. That's a nice simple way of putting it. So probably, and there's another one for building a client. This is probably a closer parallel to what we want. We want to build an AMQP client, so we'll have some function that does that. And that'll be the thing that we'll probably pass in things like the AMQP URI, and we'll also look to see what other options are part of that thing as well. So we'll get into that in a moment. What we'll do first is we'll actually just create the skeleton crate for that. So what I normally do is do something like this, where I say make a new library, and we'll call it mod-amqp. And there's a bunch of explanation here. So in KumoMTA, we use a workspace at the top level. At the moment, this crate we just added isn't reachable by any of the other crates that are in this workspace. So it's just saying, you need to do something to make that show up. So we'll do that. I'll link it into KumoD, and we'll go along to like where that HTTP is. Basically, we'll just copy the HTTP line and make it into AMQP like this. There we go. And now if I switch over here and I just sort of compile that, it's going to build essentially an empty module that doesn't do anything, which is fine. But we want it to do something. So what we'll also do, if we open up the HTTP cargo manifest for this, and then we're going to just basically copy and paste some stuff. Like any good programmer, we know how to copy and paste. So the dependencies here that we need, we'll probably keep Surdy in here. Yes, I think we'll keep Surdy in here. Anyhow is used for making error handling a bit easier. Config is a Kumo specific crate that deals with instantiating the Lua runtime and stuff like that, and has some helper methods. mlua is the actual Lua runtime itself, because we need to reference its types in here. And Surdy is used for serializing and deserializing information. mlua, you can see one of the features we've enabled in mlua is this serialize feature. This is kind of nice because it means that using Surdy we can define or derive a serialization for Rust data types, and then we can use that to essentially read the data structure that you define in your Lua code and map that into a native Rust structure, and then we can use that inside the internals. So it's very convenient because there's less manual data manipulation. Often when you're building this kind of an embedded runtime, a lot of the boilerplate really just turns into like moving data backwards and forwards between the runtimes, and it's kind of tedious and it can be very error prone. And Lua in particular has a kind of an interesting data model where you do a lot of it's almost like writing assembly code but in C, where you kind of like push and pop a bunch of things, and it sort of like arranges to return values by leaving on top of a stack. So that's definitely, if you're doing direct C code into the Lua runtime, there's a lot of that and it can be very tedious. mLua makes a lot of that just disappear. Almost all of it is invisible to you, which is really nice. So there we go, we've got those. The other thing that we want to pull in here is actually that the library that we talked about a while ago, this lapin. So here you can see it's lapin 2.1.1, so we'll just add that in. This is supposed to be alphabetical, so we'll just do 2.1 here. That'll automatically go up to 2.1.1. So if I just compile that now, again, it doesn't do anything really, it's just sort of building of the dependencies. We can see it's pulled in a bunch of stuff. That looks like it's building. Cool. So now what we want to do is, in our new module, this is just the sort of basic skeleton that the cargo new created for us. We want to look at the HTTP guy, and we're going to pull in the boilerplate for registering with Kumo's runtime stuff. So we'll just get rid of a bunch of this. We don't need request in here because that was from the HTTP, but we do want to get this guy, that register method's on the bottom. Oops. Stick that in there. And in here we're going to have an AMQP module instead. And AMQP module. And here we'll just be nothing useful. I'll explain more about this in a moment. Let's just make sure that compiles. No, it's unhappy. Oh no, it's not really that unhappy. I see. It is unhappy, but not for the reasons that I thought. Okay, so now it's going to, there's a lot of, it's moaning here because we're not really using any of the stuff we've added in. We will in a moment. So there's that. The other thing that we need to do is add this module to the list of modules that Kumo registers. So we'll stick that in here. Oops. Like so. So let's just verify that again. Cool. So we've successfully built a module that does nothing useful. In fact, it will panic at runtime because of this to do with it. But there we go. We've got our skeleton. So great. Now we need to look at the docs for lapin and figure out like what we're supposed to actually do to write an equivalent of that Python script that we're using to test publishing. Where's your docs gone? Cool. So the goal here is figure out what we need to do to configure a channel or a connection, or really both. In our Lua runtime, we don't want it to be too complicated to use and expose like all of the possible options that anyone might ever want. We just want it to be basically like, hey, just throw in my URI, and maybe there's one or two things that are commonly changed, but that's essentially it. We just want to make it fairly straightforward. So what we're going to need is like, so one way we could do this is we could have just a string for the URI and then just kind of hide the sort of, this intermediate stage. Maybe I'll try that first. Let's see. Let's have a look at these types though, because there's a channel and a connection can contain multiple channels. So we look at connection first of all. It has connection properties. Let's see what that looks like. There's a locale field table. What's that about? Some kind of map of stuff? Who knows? And then the executor and reactor. Okay, so that was that. That goes back to that Tokyo example that I was looking at earlier. Let me pull that back up. So just close that window. This guy. Alright, so a lot of that I think we'll just hide. Actually, there is something that's maybe an interesting nuance. So, while we use the Tokyo runtime in KumoMTA, mLua it has some complications in the current version. So, in mLua, the asynchronous operation. So when you create an async method or you're using it in an asynchronous context, the futures that it creates are not send. So what that means is they can't be moved from one thread to another, and that's not an inherent limitation of the underlying Lua runtime, but it's complicated to ensure that things are fully send safe. So it doesn't do that. What that means is in the embedding inside KumoMTA, we actually have our own runtime dispatcher for this. So we actually create a separate set of thread pools that is, we create a separate thread pool that is distinct from the Tokyo runtime's thread pool. And when we dispatch our asynchronous Lua code, we take care to dispatch via that runtime. In practice, what happens is if we're receiving an incoming session, when we accept the new connection, we'll randomly pick one of those, or round robin, I forget which we actually do, but we'll pick one of these threads from our special Lua thread pool, and we'll just run that connection on that thread, and we stick to that thread for the duration. Oh, sorry, I just saw a question here in the chat. Which editor am I using? I'm actually using a terminal I wrote called WesTerm, and inside that I'm running Vim, and it's just regular Vim with basically a setup that is almost the same as I've been using for 20 years. So it's nothing super fancy. It's just I am very productive in it. So anyway, let me resume waffling about this. So because we have a slightly different dispatcher for the runtime, that may influence this stuff here when it comes to integrating this. We'll try it first by referencing the Tokyo runtime, but I am anticipating that it may not work and may have to do something slightly different. So, okay. So I think the game plan really is if I just make a build client function to go inside our AMQP module and have that make a connection. Let's see, what do we need on the channel? That was the other type that's related to this. So we call connection create channel, and it just gives us a channel. Okay. Let's see. Oh, there's a lot of stuff. Okay, so I think the state that we need is essentially like a tuple of channel and connection, because I'm assuming we need to keep them both alive. Actually, it doesn't actually have an explicit lifetime between the two. So maybe we don't need to keep the connection alive explicitly. Right, it doesn't say that. Restore block topology. Okay. Alright, so maybe we can just keep track of that channel. Alright, let's try and bashing out some code here for this thing. So what I think we want to do is we'll make our AMQ, I can spell it, AMQP client. Now one of the other nuances of mlua is you can expose native types through into Lua using something called a user data type. That's essentially a pointer to some memory. Rust doesn't really like you having arbitrary pointers to memory. We need to have a bit more control over, not control, it's a bit more discerning, shall we say. So while I would like to just say to the Lua bindings, hey, here's my AMQP client, here you go, it's a little bit more tricky. The struct that we expose to Lua needs to be cloned so that it can essentially copy it in multiple places as it gets pushed into stacks and things like that. So we don't want to literally clone the connection, we kind of want to do it indirectly. So in practice, a lot of these modules, we end up making an arc to manage a shared pointer reference to the actual underlying state. So that's what we're going to do in here. We'll just call this, it's going to be a channel. So we'll do something like a, I don't know if I might need a mutex of it, but I'll just not do that for a start. Actually, here we go. Let's import some of these types first, right? Lapin. So we're going to want a channel and a connection. Pull those in. I think we're going to want that. And then this build client, we're going to take the URI, make it a string. And let's, what am I supposed to be doing with this again? Oh, actually, let's go to this example again. So there's a URI, it's going to look something like that. That's going to be the string that we get. And then we're going to go options. And like I said, this is probably wrong, but we'll try it and just see how spectacularly it breaks. And then we'll copy those in. We don't like unwraps. We really don't want unwraps here. In general, whenever I write Rust code, whenever there's a naked unwrap, I try as much as I can to get rid of it. Usually, if you're in a function that returns a result, you can map it into some kind of error result, and that's usually the best thing to do. If for some reason there's like a truly impossible condition and it just doesn't make sense to map it as an error, or there's no actual way to map an error, I always prefer to swap the unwrap with expect. Expect is functionally the same as unwrap, but it requires that you pass in a reason for the panic, so you can at least annotate that call site, and that way when somebody goes to look at the code later on, they can see and say like, oh, why is it doing that? And then they can check the assumption and verify the assumption. It just makes it a bit easier to reason about the code later on. So there we go. So that's what we're going to do here. In Lua, because we're being called through Lua, there's an implied, so actually I pointed to this result up the top here. That isn't actually the one that matters in this context. So here we're making a function. There's an implied result here that's being inferred from this guy. The actual return type here is an mlua error, which is not as, it doesn't support as many kind of different things as the anyhow result. Like it's mapping errors back into the Lua runtime, so it's a bit more restrictive. So we need to map them. There's a map error combinator that we can use here, and one of the things that we have, so up the top here you'll see there's this any error. This is just a little helper function that's in that config crate that I mentioned earlier that just maps errors that implement the Rust standard error types into a special user-defined error for the Lua runtime, and that will get like mapped through Lua runtime and back out the other side on the other end of KumoMTA, because KumoMTA is essentially sandwiching this runtime. So we've got like the native code starts, then we run into the, call into the Lua runtime, and then that's going to call back out to this code that we're writing here. So anyway, the map error thing and any error will let that kind of bounce through that layer and come out the other side. So we'll just map it this way by passing it in here like so. And then we use the question mark operator to propagate the error if there is an error. And we'll do the same thing for this guy down here. There we go. And the formatting looks terrible, but that's okay because we use a code formatter and it just fixes it for me, and I don't have to worry about counting spaces or anything funky like that. So what have we got? We've built a channel, made a connection. Oh yeah, so we actually want to return that guy. So we want to return AMQP client channel up new channel like that. And then this is probably not going to compile because we need to implement that Lua user data trait. Oh, and also this URI up here, you can see we've got a string, we just need to take a reference to it up there. Like that fixes that error. And oh yeah, we're not in an async method, of course. I see, because this is async. So we need to make this an asynchronous function. Oops. And the way that works is a little bit different. If I remember correctly, something like this. Yes, have a look back over here. Where are we? Async. Yeah, that's slightly different as an example, but alright, let's see what it says about that. Cool. And of course it doesn't... Okay, there's a few things we need to pull in here. This is this.
Prepare to witness my true power.
Tokyo executor trait. Oh, that's something else we've missed from that example.
Die, human.
Where does that come from? What's that about? Are they pulling in something funky? Tokyo executor trait. Oh, that's new to me. Let's grab those. And let's just check the version of those too. Tokyo executor trait. 2.1.1, and the React trait probably similar. Okay. I may end up removing those because, like I said, I think we probably don't want to do that. Okay, so those are those guys. And okay, yeah, so we need to implement this Lua user data trait. Lua user data for MQP client. And it doesn't do anything useful right now, but it should satisfy that, and you should be able to compile. Yes. So we're compiling. We've still got a bunch of issues we need to actually fix before it does anything useful. But right now, what we have is sort of bare minimum thing where we can create a channel, and then that channel returns an object that we can't do anything with, but it should be connected to whatever URI that we set up. So great. We probably want to add some methods on here. So let's go, where is it? Add methods. Oops. We'll just copy this function signature here. And I think we're going to want like a publish. And actually, is it asynchronous? Let's have a look at this. Where's that example one? So when it publishes, yeah, it awaits. So we need our publish method to be asynchronous. So we'll add an async method, and we'll call it publish, not publish. And so if we look at some of these guys in this other module, you'll see there's a lot of punctuation looking stuff here. This first underscore is being ignored in that particular method. That's actually the Lua runtime context. This parameter is the object itself, which in our case will be the AMQP client. And then the remainder is like a tuple of all the arguments that were passed to it. So we're going to sort of replicate that same general thing here we might actually need the Lua runtime. Actually, no, we won't. We probably won't in this case. And then something. We're going to want something here. I guess the question is, what exactly are we going to publish, right? In that example, it's a string. I guess if we go look at that Python example that we were looking at earlier, whatever that was. What's this guy? This is CLI. Will I end up closing the Python example? Okay, cool. They're just sending a string. Yeah, so I think what we'll do is we'll make this a Lua string. So in Rust, the string type, capital S string, is a sequence of a vector of bytes whose encoding is UTF-8. It's not an arbitrary binary string. In the Lua runtime, the string type is actually an arbitrary byte sequence. The mlua bindings will let you map for that. So like I could say string, and then in the glue in mlua, it will ensure that it is actually UTF-8 and will raise an error before it calls into our actual implementation. It could actually be desirable in our use case to allow binary here. So if we make it an mlua string, then if we just say the convention is you generally use UTF-8, but you can also do binary if you really wanted to, this would allow a binary data to come through. And there are methods on the mlua string that allow us to figure out, oh, is it, can it be representable as UTF-8 or is it just binary? So I think what we'll do is we'll do that. That allows us to publish an arbitrary byte sequence if we wanted to, and kind of go from there. So this defines the skeleton of that publish method. And what we're going to want to do is do something like this channel. Let's look at that example over here. Channel basic publish, we're going to need to say which queue it is, right? So we do need some parameters here. Let's have a look at the actual docs for that channel basic publish. Exchange routing key options payload. Okay, yeah, so the payload is an arbitrary byte sequence, so it was a good call to accept bytes there. All right, so we might need a bit more advanced. Oh, interesting, you can set the content type. All sorts of interesting parameters on here. Whoa, okay. Well, some of these are reporting rather than setting. Okay. Okay, so there's some properties that could be set. And basic publish options, mandatory immediate. Okay, so we're going to need something a bit more than just the string we want to publish. So essentially we're going to want a struct with these guys in. So I'm just going to copy that, and we're going to just define one. So we'll stick that up here, and we'll do, what is this? Let's call this publish params. And we'll just make the strings actual strings rather than references to strings. And then the payload. This is a bit more fiddly. We might be able to get away with this. We'll see. So this is essentially the type that we want to pass into the publish method. And the way that we're going to make that work is we're going to take advantage of that SERDI serialization thing that I mentioned earlier. The way that we do that is we change the type of this to be a general Lua value parameter instead of of anything else. That corresponds to one of these use clauses up here that was sort of moaning about earlier. This is similar to like a SERDI JSON value conceptually speaking, but really it's like any Lua runtime value, right? It's an enum that represents the set of types that Lua recognizes. So the game plan is we'll accept any one of those, and then in the body of our method here, we will ask Lua to do like a serde deserialize for us, and that will take place using this serde-ext trait that mlua provides for that purpose. That's an optional feature. That was that serialized feature that we turned on in the cargo toml. But in order to do that, this publish params, this also needs to be deserializable. So let me sort of demonstrate this a little bit here. This should compile. Let's see. Oh, not quite. We need to derive clone on this guy. This is what I mentioned earlier. So this should compile. Oh, almost. Now we need to pull in these types. What else does it want to do? Publish options as well. Okay, so it compiles. Again, there's still a bunch of noise in there, but like, you know, it's essentially there doing something. What we're going to want to do here is we're going to want the parameters to be these publish params, and we actually do need the Lua runtime now. And we're going to say from value, and that should coerce it. I know that this is going to raise an error because we haven't derived deserialize yet, so I'm going to just put that in here. Deserialize, and we'll also put debug on here for convenience when error, like dumping stuff for errors. So let's see what it makes of this. Cool, so that compiles. So you can see that's kind of very powerful because really I just said here's a set of parameters here, and then it just derives the boilerplate code and then stuffs it into that type at runtime. So what that means is when we call this publish method, we're going to end up with some code that looks something like this. I sort of sketch out with Lua. It's going to be something like client publish, and then we can do things like exchange equals whatever the exchange is. Again, I don't really know AMQP, but actually, if we look at that example over there, routing. Oh, so that's actually the queue. So, and then we've got publish options default. Interestingly, that seems like it's serializable. So we may have automatically been able to pick up these publish options just by deriving that stuff. That's handy. So, in fact, what we may want to do here, as specified right now, we have to put something in for these publish options. So I actually don't know what those look like in practice yet, but like, if we want to be able to leave them out, we need to mark up this structure a little bit differently to tell serde that it's okay to be optional and fill it in with the default or something. And then payload is the actual message that we're going to send. So that's something like that. And then we've got properties again. That the fact that it compiled and hasn't complained is interesting because it means that both of those types are serializable, and we don't strictly need to define them. So that's kind of interesting. Let's have a look at the definition of those so we can see what's going on there. Yeah, you can see they've derived deserialize and serialize. Cool, that's kind of handy. And it has default. Cool. So what I think I want to do is tell serde that can be defaulted, and the same for this, and probably also the exchange. If an empty string is cool, that's cool. So the thing that so the two required things, if I pull them out up here, actually, these are the sort of two required parameters, like where it's going to and the payload. So, and then the rest are just optional and get filled in with defaults. That seems pretty powerful, and we didn't have to do a lot of things. We just had to declare the information on the struct, so that's kind of handy. So then what we can do is this channel, what was it called? Basic publish. And then we do something like params exchange. routing key. Params options. Params payload. And then params properties. Like that. And it's async, so we need to await. And it returns a PublisherConfirm. So whatever a PublisherConfirm is. I see, so we can wait for it to act strongly on the other end. I guess that's what that is. So it is itself a future where you can wait for a confirmation. So that's kind of an interesting thing because I'm assuming that you can just ignore that if you wanted to. So there's sort of two levels of durability there, right? Like one is you could say like, hey, I just want to fire the message off, and assuming that I fired it into the queue, that's all I care about, and we can carry on and do something else. That's probably what most people will want for this thing. But if for some reason you're especially paranoid that something could go wrong elsewhere in that pipeline, then you may want to wait until the consumer at the other end has confirmed it. I'm assuming that's what this thing is. And oh, look, there's like a way to return a status as well at the other end. So this is the kind of thing where we don't want to assume either use case. We want to allow our users to decide in their integration which one that they do. So we will need to write another little wrapper around this confirmation thing so that you can choose to use it if you wanted to. Great. So we need a PublisherConfirm wrapper. Let's do this, and then we'll map that error to any error again. So at the moment I'm just ignoring it for the sake of compiling this example. Cool. And nice. So it looks like I'm going to clean up some of these guys because I don't think we need a bunch of these right now. And they're just kind of making it noisy, making it look like my code is crap. So let's get rid of that guy, and this guy, and this guy. And we're left with a couple of things. 62, we don't need that anymore. This time. And then the other thing is got that confirmed, which we know we want to do something with. I'm going to leave that there because we know we need to do something with confirm in the final state. But if I check that, it's building okay. So what we can try and do here now is actually we can try doing like building it together, and I want to see if we can actually send something, have it show up over here in this receiving screen. So we'll see how that goes in a second. Just let it build. So far I've just been running cargo check. Cargo check just does syntax checks. So it's like it's almost the same as running the full compiler. It will catch almost all of the same errors that you would get if you were building it for real, but it happens to run much, much faster. Now I'm actually building it for real, so it needs to do a bit more work. And there we go, it's built. So what I tend to do when I fiddle with this stuff for like ad hoc testing, I've got like a simple policy Lua script here. Usually what I'll do is I'll stick something in the init event at the top and just have it like do some stuff. So what I'll do here is like make a client, and we'll do KumoMTA build client. Is that what I called it? And I pass in the URI, which is going to be like AMQP localhost something. We'll just copy whatever we did over here. Oops. Oh, we just said localhost on that one. Maybe that's what I'll just do. AMQP localhost. That makes a client, and then I'm going to try basically what I said earlier. If we go back to that thing I sketched out. I'm just going to do routing to. Where are we connecting to? Hello. And then payload. Root. So hopefully that will work. And then I'm just going to run KumoD. Actually, I don't need it to be in debug mode. I'll just run it with info. So hopefully what we'll see, or maybe I'll add some, just for the sake of exposition. And this may or may not work. Again, because of that Tokyo runtime thing. So let's see what happens when we start it. Okay, what have we got? Invalid type string expected table. Really? What is something wrong? I think the issue is this guy. So if I just make this a string for the moment, let me just confirm my suspicions first of all, and then is it as bytes? Cool, and then build that. What I think is doing a vector of bytes probably wants me to have like an actual Lua table of bytes in the way that the serialization works. So I have to get a little bit more clever with that if we do want to allow raw binary. But for the moment, we'll just use a string and see if that does the job. So let's try running this. Cool, it said it published, and actually, look, it worked. Fantastic. So basically we're done. Now we just need to tidy this thing up a bit more and see what we need to do around that. And that's basically it. I guess we should try some of those other parameters maybe and see like how those work out. It's not a bad idea. See, those are useful properties. Oh, the confirm. That's what we need to do. Yes. That's more important than messing around with those things. Cool. Let's do that. We can close this. Yep. That. So we need to make a little wrapper for that confirmation. So this is going to look similar. How long we've got. I'm just going to call it struct confirm, and then this needs to be an arc of whatever that is, publisher confirm. Let's grab that. Cool. Like that, and then again we're going to need to make that have a Lua. We'll just copy the skeleton. Cool. It's the same here. Oh, we haven't used methods. That's okay. Alright, we're never doing anything with that because we haven't written any implementation yet. Okay, so now our publish method publishes and it returns that confirm guy. And what we want to do on here is add a method like wait or something. Let's have a look at actually what this type is so we can see what we're supposed to be doing with this. So PublisherConfirm is just a future and it returns a confirmation. And then the confirmation can be ACK, NACK, or not requested. and then there's a basic return message. So what I think we're going to do on here is add a wait method, and it returns essentially this thing out of here. And then what does this have? We're probably going to need to make our own version of this struct in Lua because this doesn't implement the serialization traits. And then ack and mac. So what I'm thinking about here is like how do we represent this in Lua? Probably it's a table value where we have like a field for this type. For the variant discriminator, so we can see like what it is, and then there's another field that is the return message, or the fields of those actually get mapped into it. So let me sketch that out so it's a bit clearer what I'm talking about here. So we can do something like this, and what do we call it? Type is very generic sounding. I don't know what to call that. Is ack, is nack, take message. What do the Python bindings call this? I guess it's the piker. So like Python. Docs for this. Yes. All class and modules. Channel. So these like knack methods presumably create those response types. This doesn't specify what the return value is from a publish. So it makes me wonder if there's like a separate, like a method or something in the Python client where you would say, hey, I want to get that response. All right, I think I'm just going to call it status. So we'll do a little enum. So we're going to have ack, nack, what was the other, not requested. This is essentially that same enum, but it doesn't have any of the sort of like load-bearing fields, right? It's just these names, and you can derive serialize for this. That way when we map it back into Lua, like it will just generate like the string version of these guys. So we'll do status, confirm status, and then basic return message. And hopefully these guys are serializable as well, otherwise we'll have a lot of... Oh, that's a bummer. Short string read delivered. Acker. What's this? Oh boy, it looks like you can respond to a response to your message. I don't know if we want to go that far in this client. And maybe what I'll... Maybe... I was thinking of ignoring some of this. What I think I'll do is I'll just probably take these two. So here's what's on my mind. In the context of logging, or really in any of these things. So the way this stuff works in KumoMTA is essentially what we do is we actually define our own internal queue when we go to call out to the part of code where we're going to trigger this from, right? So if you consider the webhook use case, which already exists, let me call up the docs for that. If you are doing something with webhooks, we've got an example somewhere, I'm sure. Where is it? Let's just search webhooks. Here we go. So the way that webhooks work in KumoMTA is when we've received, and again, this is going to sound confusing because we have all these different kinds of messages in different contexts. So if you zoom out and recall, KumoMTA, its primary purpose is receiving mail injected probably by SMTP, but maybe through a REST API, and then managing delivery out the other side using the SMTP protocol. One of the things that's very strongly desirable is the ability to like record when we receive something and record when we've delivered it, or record the disposition of the message on its way through the system. So the idea with webhooks is we want to send those things to some other system of record so that we can, close the loop and dot the I's, cross the T's, that kind of thing. That's fine. But like if that receiving webhook endpoint is down at the time we try to send that, we don't want to just forget that it happened. We want to try again later. So the way that webhooks are implemented in KumoMTA is we actually define an internal queue of our own because we are already a queuing system. And we manage delivery in that way. And in the context of that queue management layer, if there was a transient problem, we'll want to retry later. If there was a permanent issue with that thing, then we probably don't want to try again later on. So it's desirable to understand the disposition of like that webhook attempt. And the same applies here with the AMQP. If we've tried to publish and we didn't get a NAC, we didn't get an ACK, then we kind of want to understand like why, like so we can decide, is it something that we want to retry or is it something we just want to give up on? So sort of returning back over to this thing here, I'm making an assumption here that this reply code and the short string are the things that are going to allow your integration with this stuff to decide, oh, it's transient or it's permanent failure. This delivery thing, I think, is a bit more complicated and nuanced, and I don't know if we need to expose that to Lua. So in the type that I'm going to build here, I think I'm just going to expose these two things, and that's probably fine. Right, what is this? A short string just looks like a string, and reply code just looks like a number. So those should be easily representable here. So that's what I'll do. Reply code and reply text. We'll stick those in. We're going to make these optional because they're not present if not requested is the status. So what is reply code again? Short uint. Can I just directly use that type? And then reply, is it status I said? Short string was. Actually, I'm just going to use string here. And then this, we're going to derive serialize and debug. Just make sure that that's vaguely happy. Oh, it doesn't know about reply code because it's in a different crate. It's in that underlying protocol types crate that we saw right at the very beginning of this stream. What I'm going to do, I'm just going to make this a use size. And you know what? I'm going to make it an I60. The U60 rather, it's unsigned. So there should be no problem with that. Oh, I see. We also need to pull in serialize up here. That maybe. Cool. Alright, so we've got our kind of skeleton of that value. Now we want to add that wait method that I was talking about, so we'll just sort of sketch, copy this bit, and we're going to make a wait, and then here, there's no parameters to this wait method, and so the idea is over here we'll do that, and then we can do confirm wait, and then we can do something like KumoMTA result, which should show us what we need. Something like that. So we need to actually make that work. Which I think is as simple as this dot. Now, so to sort of refresh our memories, this confirm struct is this guy, so we need to do this dot confirm await. Map error, any error. That. And then we're going to do let's look at the types on this guy again. So the confirmation, it has these methods isAc, isNac, and take message. Take message, that's kind of convenient for us writing these bindings because what we can do is we can just call one or the other of these, or both of these, to figure out like what the actual status is, and then we can just call this one at the end to grab the message out. So what we'll do is we'll do status equals if result is act. Then we're going to do. Oh, you know what? Let's make this slightly nicer. From information. It just makes a slightly nicer way of handling this thing. So if confirm is act, else if confirm is nac, else it must be not requested. And then confirm status, confirm confirmation. Let's call that confirmation as well, just for consistency's sake. Right. And then we want to take that basic return message. Right, so we're going to want to do something like this. Let reply code reply status equals if let some message confirmation take message else none, and then we're going to end up with I'll get to that in a minute. So we're going to conditionally populate those guys from the basic return message. And that's an option, so that may not even be present. It looks funky. So take message. Oh, actually, no, it's already handled that for us. We don't need that, probably. Okay. I'm just looking at the structure. And in my mind, I was thinking, well, it might optionally be present based on this guy, and the sort of dumb way to do that is the optionality is based on this, and then naively there's just like another layer of option, but there isn't. It looks like it's sort of unwrapped that one level for us, which is good. And then in this, we just kind of get those fields out of there. Cool, so this is a bit easier than I thought it was going to be. So we're going to go message, reply code, message, reply, status. We might need to do some type conversion on that. We'll see in just a moment. So then down here, now we're going to make our own version of the confirmation using our struct. Like this. And we're going to have our status goes in there, our reply code, and our reply status. Let's see consistency. Let's see what the compiler thinks of this. This isn't the final form, I just want to kind of see if I've made a mistake. So... Really? Oh, I've done something wrong here. PublisherConfirm. It said it's not a future, but according to these docs, it is a future. So what have I done that's wrong? I mean, it's definitely a future. So the... What's going on here? It looks like it needs to be mutable, which kind of makes sense. Alright. In that case... Let's get a mutex. Let's stick that in here. This is a bit problematic. Technically, this is a bad code smell, but let's see what happens. Let's just see if this actually makes it compile first, and then we can sort of discuss what's going on with that. So it actually may not compile, because I think I know there's an unwrap there. Oh, we're just testing something. He thinks that's not a future. Let's just undo that bit. What have I done here? Have I got something confused? Oh, I've made a mistake here with this. Oh, I hate using things. Right, let's just call this... Let's call that confirm result. Just to differentiate it, because I think that's an issue. And then we can pull in this actual type. That makes a bit more sense. Okay, that's sort of gotten rid of one category of foobar. Just get the line numbers up. So, PublisherConfirm. That is this type. This type does implement future. What's a wrap? Let's just do a test here. I just want to prove to myself that something weird is going on. Yeah, you see that? That's heavy with it. What is it called? Confirmation. Okay, so the issue is that it's wrapped up in this archetype, and that's sort of getting in the way of it resolving a future. Presumably there's some internal mutability happening in that thing. Arc allows us to multiple things to reference the same value, but it's immutable, and I think that's getting in the way of this thing. And if you look at this guy over here, you can see it's got like a pin of mute self as well, so like that's definitely a factor there. So what we essentially want to do is not have the arc there, but we need the arc there to sort of pass that through the Lua runtime stuff. So what I'm going to try and do is I'm going to stick that in an optional and sort of carry that through. We need a mutex to support that, so it's going to look a little bit weird. If we do like this. So we end up with that the underlying type that we want. It could be optional, because what we want to do is like steal the value out of the Lua wrapper for that at the point that we call wait. And then the other machinery is just there to sort of satisfy the type checker that we're actually being safe in how we handle the value up until that point. In practice, we'll never have like multiple things looking at this same value. So this is a little bit annoying, but it means that it's like definitely safe. There's going to be no unexpected gotchas like trying to like free it twice or something weird if there happens to be like 2 copies of it stuffed into a stack somewhere for whatever reason. Or someone does something enterprising where they sort of try and copy this and stick it in and trigger some other Lua code in ways that we haven't considered. So let's get that, and then we'll do mutex new of some of this. Right, so we've got now a couple of layers of wrapper, 3 layers of wrapping, but it's okay. Like it feels gross because it feels like it's unnecessary, but it is necessary for the type safety to be upheld. But also the thing is the cost of just having those layers of wrapper is going to be insignificant compared to the cost of doing the network call to talk to the message queue. So it's just going to be dominated by that. So it doesn't matter. So that's fine. It just looks gross. So what that means is in here we're gonna grab confirm thing by doing something like this. Lock, unwrap. Now, I made a big thing earlier about never having a naked unwrap. My one exception is the standard mutex thing, because it's such a pain in the ass that you always have to unwrap it. I don't want to have to like explain it every single time. So this is kind of like my one violation until the next one. But this is the only one I can think of right now. So this, what we're doing here is we're unlocking the mutex and looking at the insides of it. Then what we're going to do is we're going to take the value out of that option. And we want to make that an error if someone's already taken it for some reason. So we'll do this OK or else thing here. And what we'll do is we'll just map this into an mlua error external. We'll just say confirmation already taken. thing. That's like the run number of braces. That gives us the confirm guy. Oops. And I make that mute. And then we'll do an await like this. So hopefully that'll make it compile this time. Let's see. Excellent. So now we've got like a different error, which is fine. So we've gotten past the weird thing with the await. Now we're onto this reply status. So if we look at the confirmation inside here, reply text, not status. Okay. So what we'll do is reply status is just reply text. So cool. And now I did say this would happen earlier. Now what we've got here is there's a type mismatch because the underlying types in that inner struct are kind of like these small, they're like packed variants, so like small representation on the wire. And then in the bindings, I'm assuming that they would do it this way because that's probably something I would do, is they've made versions where there's like almost no runtime overhead for looking at those packed versions. So we just need to do some conversions. And one of the things I love about Rust is you can just say, convert it into like whatever it's supposed to be. And that should probably work. Let's see what happens. Oh, so close. All right. Oh, I see, because these are options. So we need to do some of these. Oh no, that looks a bit gross. Okay, so the short string we can't just directly convert for whatever reason. Let's have a look to see what methods that provides so we can see what we need to do. Yeah, we just have to do this astra. It's a little bit frustrating. Astra toString. So that way we get a reference to the sort of underlying byte slice that was there, and then we just convert it into a string, and that's probably going to make that compile. Cool, now we've got some unused stuff. Well, that doesn't need to be mutable over here. Cool, so we get rid of that. Information. Oh yes, and the thing that we've missed is actually returning this. So we've put it into this shape, which isn't even its final form. We need to like transform this now into something that is represented in Lua. What we're going to do here, because I used the serialize trait on here, I can do the opposite of what the trick we were doing earlier and get like the Lua serialize stuff, mlua's serialize stuff to handle it for us. So that we do like this. We say to value confirmation like that, and then we can do result. And I think that raises an error potentially. So I think that will do the job. So this will cause it to serialize into a Lua value in result. And then we're just going to return that. So let's see. Ah, so close. Just need the reference to this rather than the actual value. There we go. Sweet. And then let's just format it to make it look a bit nicer. So now we've got our wait method, and then we can try running that and see what comes back. We haven't done anything to sort of acknowledge that in that Python code, but I'm assuming that it would show the right kind of thing. So let's try building it, and we'll try running it and see what happens. Cool. And let's run it. Cool. So we can see there was no status requested, and these other guys are null in here. Pretty neat. I wonder if we change one of these to do like a reply mac over here, would that work out? Let's. Apparently I've got one still running. Where is it? No? No? or jobs as the... Really? Okay, there it is. Somewhere lurking. Okay, so in the receiver, what I think, if we go back to that Python example, not there. I'm guessing that we can do like a knack. Basic knack, basic knack, not back. Basic knack. Maybe. Auto back. Basic knack. Alright, I'm going to try calling basic knack. No, that doesn't seem right. Or maybe it is. I don't know. I see, this is the Python equivalent to that logic. Yeah, let me just try calling chow basic knack. Maybe that will do the job. Receive. Let's just try transmitting one. And then delivery. Really, I don't know what I'm doing. Server assigned delivery tag. Is that something that you set when you send? I think is the question. Why don't I try something else instead, like we just try raising an exception in that handler. No, that's... Oh, it just kills the whole program. Alright, I don't know how to do knacks. I think that much is clear. Properties. Maybe there's a property on here that we can... Basic properties. Alright, this is... Here we go, basic properties. how to do a knack. Here we go. Delivery tag. So they're just iterating. I see. Frame. Did we get the frame? I guess that's method, isn't it? So presumably there's a method delivery back here. One. Okay, another two. Okay, cool. That's what we want. So here we can do channel basic net method delivery tag. So now if we do receive and transmit, we'll just learn to spell. Not this one. Really? Oh, because of auto hacking. There we go. So it's just going to retry forever because it's terrible. So what we should probably do here is do like a random thing. How's random work in Python? Is it math.random? Forgot how to do Python random numbers. Oh, it's just random. Random. Cool. Alright, so we'll do if random greater than 0.5, then alright, so this way we've got 50% chance of knacking. And then if we try and transmit, is it doing it? I don't know. Let's just see if we can be a bit more assertive with that. Yeah, okay, so you can see oh, we didn't actually act, so we need to actually explicitly act as well, because we said we didn't want the auto act. Okay. So now if we run it again, we shouldn't see those. Cool, because they were being re-queued each time I ran, it would be redelivered. So we act that one. And then you can see there's some max. And then activate. Cool. Alright, so we've got a thing that will do a knack. Now if we rerun our thing over here, hopefully we'll see we'll get a knack sometimes. Not sure. Let's try another one. Alright, not sure what I'm looking at here. Okay, so in this case, that information didn't propagate all the way back, presumably because there's not a thing that we need to do something to sort of connect those dots together. It's like maybe the common case is that that's not hooked up. But regardless, I don't know. I might come back to that in a bit. One of the things I want to do now is just kind of sanity check where we got to with this. So let's have a look. What have we got here? Stuff. Let's look at the changes we made. So we've added some dependencies. Some of these it might be nice to turn off. So you can see we've got these like async global executor thingies. I wonder if I can turn those off from Lapin so we just don't end up building them, because we're not using those. I don't know if it needs it internally to dispatch stuff. So let's take a look at its feature flags and just see, can we turn that off? Looks like no. So that's okay. So I'm just going to ignore that then. Just add more weight to the thing. That's fine. It's not a big deal. A bunch of stuff there to support that. Blah, blah, blah. And then these are the changes that we actually did intend to make. So we added our AMQP thing. We've got it registering. You can see that in this simple policy, my sort of test bit of code. And that doesn't include the crates yet, so what we'll do is we'll add that in, and we'll just take a look at that. So it's really just the file, which makes sense because that's all we really did was add a file. So in terms of what I would commit, it would be those. This doesn't include things like the documentation. I don't know if you, the audience, are interested in seeing how we do the docs. Essentially, it's adding some markdown files for like each functional method, or just explaining like how to use it. But that's essentially it. That's basically doing the job. You can see it ended up not being that much code. What is it, 140 lines really? And ended up being pretty straightforward. Excuse me. So not a huge amount to it, but like a lot of potential power available there, especially because there's a bunch of options here we didn't really explore, but like they're seemingly supported. I know that seems kind of like oh, that's a lucky bonus. I'm not super worried about like digging into those right at this moment in time. The purpose of this really is just to get it out there and just get it in the hands of some of the people that express interest in this feature, get them to try it out and see like, okay, are we missing an option or a way to set an option or what have you, and then just see how we go from there. So that's pretty much it. I think I'm gonna wrap up here. If you've been watching, thanks for watching. I would love to hear feedback on how you thought this went. And I plan to do some more streams like this in the future as we add more features. So thank you, thanks for watching, and bye for now.